Now that we've done some review of composite functions, I think we're ready to start talking about the chain rule. So let's dive in. It says if y equals f of g of x. So it starts off by assuming that we have some sort of composite function, some sort of function inside of another function, which is why we needed to talk about that in the last video. Where g of x is equal to u is simply going to be a placeholder variable for us right now. So we'll see how u works out. I wouldn't worry about that part. Then y prime equals dy du. This says the derivative of y with respect to u times du dx. This is the derivative of u with respect to x. If you don't like that notation, we can also use y prime equals f prime of g of x times g prime of x. And as I look at this, I don't know that I really care for either one of these, so I'm going to give a third that we can use, and I think this is what I'm going to use. It says y prime equals f prime of u times u prime. And I think this is the notation that I'm going to use. So the chain rule is, I think it's a lot more, it's difficult. I think it's more difficult than the product rule and the quotient rule. So what we're going to do is we're going to start with this general chain rule, because this is a chain rule that will work for any function. And we're going to see if we can look at some cases that all kind of look the same and see if we can come up with a formula for the chain rule that'll be a little bit easier for us to use. We'll kind of say all of the functions that we look at will kind of fall into one of three cases, and if we can identify which case it looks like, we can just use that formula, which I think will be a little bit easier to use. But before we do that, I'm going to give a procedure to use this general chain rule in case you want to continue to use the general chain rule, or just so that we have a procedure to follow for these first few functions. So I'm going to give a step-by-step guide here, which will hopefully make using the chain rule a little bit easier. You're going to identify an outer function, or sometimes I'll call it an outside function, f of x, and an inner function, g of x equals to u. Oops, not y, g of x equals to u. So this is actually the same step that we were doing in the last example to the previous video, where I was looking for f of z, I was looking for g of x. It's the same exact idea that we were using here. Once you've identified your outer and your inner functions, you're going to, in your second step, you're going to replace g of x with u. You're going to rewrite your function in terms of u. So after this step right here, after step 2, I shouldn't have any variables of x. I should only have u. And the function overall should look a little bit simpler. It should look a little bit easier to handle. Because in step 3, that's when we want to go and actually apply our chain rule. We're going to calculate either, really any one of these three. You can say dy du times du dx. So we could use that. You could use f prime of g of x, f prime of g of x times g prime of x. We could use that. Or we can use f prime of u times u prime. And then last step here, so at this point we'll have our derivative, but our derivative will be in terms of u. But I start with a function in terms of x. If I start with something in terms of x, I want to end with something in terms of x. So my last step then, I'm just going to do a little bit of substitution here. I'm going to replace u with g of x and u prime with g prime of x. So I think these 4 steps will really help us to use this general chain rule. And again, I'm really just hoping to use this general chain rule to see if we can establish a more concrete formula for a more specific example, which we'll hopefully get to at the end of this video. So we're going to start by looking at the derivative of 3 functions. The first function I have f of x equals 4x squared minus 10 raised to the 3rd power. Off to the side, I usually like to do this off to the side. I'm going to identify my outer function and my inner function. And I think my inner function is usually easier to pick out. In a case like this, when we have parentheses, those are usually a really big hint as to what your inner function should be. Most of the time, your inner function is going to be whatever's inside of those parentheses. So off to the side, I'm going to find u is 4x squared minus 10. 4x squared minus 10. And I'm also going to, because later on, I'm going to need to find u prime. And I should have included this in the first step. I apologize. But I'm also going to just find u prime right underneath it. I'm going to find the derivative. So the derivative of 4x squared minus 10, that's going to be 8x. And that's my step 1. Over here in step 2, well, I really have a little bit of step 1 left to do. I'm going to replace g of x with u. Well, what did I say u was? I said u was 4x squared minus 10. I'm going to take out this 4x squared minus 10, and I'm going to replace it with u. So let's see, I'm going to use y here instead of f of x. I think that's a little bit easier. Y equals u raised to the 3rd power. And that's it. Our goal here with this step is to come up with a function that's a lot simpler to work with, something that we can take the derivative of. I know how to take the derivative of u to the 3rd power. I just use my power rule. So okay, we're moving right along here. Step 3 is when I need to find that product. So I'll either be using dy du times du dx, f prime of g of x times g prime of x, or f prime of u times u prime. And I think that last one, like I said, I think this is the one that I'd really like to use because I think it's probably the easiest to understand. So y prime, here's my derivative. When I say f prime of u, this part right here, I'm really just talking about the derivative of this guy. So what's the derivative of u cubed? It's just 3u squared, so that's this part, times what's u prime? Well, I have that over here. We found that earlier. For now, though, I'm going to leave this as u prime, just so that I do all my substitution in that last step. So let's just leave that as u prime for right now. And then my last step, step 4, I have the derivative, but it's written in terms of u, so I just want to rewrite this so that it's in terms of x. Y prime equals 3 instead of u. I want to rewrite that with 4x squared minus 10. So I have 3 times 4x squared minus 10 to the 2nd power times u prime. Well, u prime was 8x, so times 8x. I think this is fine. If you wanted to, the only simplifying I would do here at the end is we can multiply 3 and 8x. Since we have 2 monomials, it's pretty easy to do, so why not? I'm going to multiply those 2 together. I've got 24x times 4x squared minus 10 quantity squared. This is how I would write my solution to that problem, or how I would write my derivative. Because that's what we found. We just found the derivative y prime, or f prime of x. Alright, so let's see what else we can do. The next example here, I have y equals 3 over x to the 4th plus 1. Before we get going, I'm going to rewrite this for reasons which will hopefully become clear in just a little bit, I'm going to rewrite this as 3 times x to the 4th plus 1 raised to the negative 1st power. So I'm just going to rewrite that with a negative exponent. And there's 2 reasons for me doing this. The first is, once we rewrite it, I see these parentheses. Again, I think that's a really big help in identifying what that inner function should be. So my inner function u is going to be x to the 4th plus 1. Underneath it right away, I'm also going to find u prime, its derivative, that is 4x cubed. So now there's the first reason. I think it makes it easier to pick out u. My next step, I'm going to rewrite this so that it's in terms of u. So this really says 3u to the minus 1 power, because x to the 4th plus 1, we really said that that was u. The second reason why I wanted to take a step to rewrite it is because this is now something that I know how to take the derivative of. This I can take the derivative of using the power rule. I suppose I could have used the quotient rule earlier, but this problem's already pretty complicated. We're already using the chain rule, which is a whole new idea. I'm not ready to use the chain rule and the product rule at the same time. So this is just going to be a power rule. So that in my next step, step 3, I'm going to take my derivative. So the derivative of 3u to the minus 1 is just a power rule. So negative 3 times u to the minus 2 power times, again, times that u prime. We're going to be multiplying by that u prime in every single one of these examples. So times u prime, that is 4x to the 3rd power. And actually, whoops, I said I was going to leave that as u prime, didn't I? Let's leave that as u prime. Step 4 then, now I'm going to go ahead and make that substitution. I'm going to take out my u and my u prime, rewrite this so that it's in terms of x. So y prime equals negative 3 times u. U is x to the 4th plus 1 raised to the negative 2 power times u prime. U prime is 4x cubed, so times 4x cubed. Again, we can simplify this a little bit. I don't think it's too bad. I'm going to take negative 3 times 4x cubed. I've got negative 12x cubed times x to the 4th plus 1 all to the minus 2 power. And if you really wanted a positive exponent, you could rewrite this as negative 12x cubed all over x to the 4th plus 1 quantity squared. I think either one of these last two is probably how I would write my derivative. My last example here, I have f of x, and again, I'm just going to call this y. Y equals square root. Oops, let's get rid of that too. Square root of x squared minus 6. And just like I've done in the last example, I know I'm going to want to take the derivative of that square root, so it's probably easier just to rewrite this as x squared minus 6 to the 1/2 power. Now it becomes easier, I think, to pick out my u. U is going to be x squared minus 6. Let's find u prime as well. Derivative of x squared minus 6, that is 2x. So my second step when it comes to rewriting over here, y is equal to, I'm going to take out my u, which is x squared minus 6, replace it with u. So this really says u to the 1/2 power. Again, we're looking for something here that we know how to take the derivative of. I know how to take the derivative of u to the 1/2. If after you've chosen your u and then plugged that u into your function, if you end up with something that you can't take the derivative of, you've either chosen the wrong thing for u and you may want to go back and try something else, or you've made a mistake when substituting it in, because what we end up with, this guy right here, should be simpler than what we started with. So step 3, I can take the derivative y prime. Here this is just a power rule, so 1/2 times u raised to the negative 1/2 power times, again, multiplying by that u prime, multiplying by that u prime. We're going to include that every time. So times u prime. And then in step 4, I'm going to replace my u and my u prime. So y prime is equal to 1/2 times x squared minus 6 raised to the negative 1/2 power times u prime. U prime is 2x. Again, this one simplifies really nicely. We've got a monomial. I see, let's see, a 2 in the denominator, 2 in the numerator. We can cancel those. So we can either write this as x times x squared minus 6 raised to the negative 1/2 power. I think that would be a fine way to write it. Or x divided by x squared minus 6 to the 1/2 power if you wanted a positive exponent. So I'm hoping that we kind of feel like we're seeing a pattern with these 3 functions. They all kind of look the same after I've rewritten them. They all kind of look like variations of the power rule. Here I have something raised to the 3rd power. Here I've got something raised to the negative 1st power. Here I've got something raised to the 1/2 power. So I'm trying to kind of come back to this idea of the power rule, which is something that I know how to take the derivative of. So if I want to take the derivative of a function y equals f of x to the nth power, then actually let's rewrite this so that it's more in line with the notation that we were using. We'll say if y equals, we'll use g of x because that was the inside function, g of x to the nth power, or if you want to simply write that as u to the nth power, then, so what does the derivative of this look like? Well, let's look back at each one of these. If I look at what I had right here, I had u to the 3rd. What did I do? Well, I multiplied by my power, subtracted 1 from my power, multiplied by u prime. What about in the next example? Well, I had 3u to the minus 1. I multiplied by my power, which is how we came up with that negative sign, subtracted 1 from my power, multiplied by u prime. All right, let's check this last one here. What did I do? I had u to the 1/2. I multiplied by my power, I subtracted 1 from my power, I multiplied by u prime. So if I want to take the derivative of this function, y prime, what am I going to do? Well, I'm going to multiply by my power, n times u, subtract 1 from my power, so I should have to the n minus 1, times u prime. So here is the general formula that I am going to use for the power rule. So if you have something that looks like this, you have a function raised to the nth power, or maybe we write, oh my goodness, I can't speak. We rewrite it as u to the nth power, we can always fall back on this formula. So this would be a good one to highlight or star in your notes. If you feel comfortable using this four-step process, by all means, please feel free to continue to use it. But I know that a lot of us, I think, feel a little bit more comfortable when we have a concrete formula. So this is one that we can fall back on. This is one that, if you like this formula, I would definitely have it memorized. In the next video, we're going to see if we can expand the chain rule here to talk about exponentials and natural logarithms as well.